when you make a part, you gotta make sure your material is defined correctly. Everyone should know how to do this by now, but you can just say edit material and then pick whatever material it is. Any material we give you in a problem will be in SolidWorks. You'll be able to find it somehow. But that's really important because, you know, the material defines everything. It's mass, its density, everything. So make sure that is applied. And then to find the mass of the part is really easy. If you go under the Evaluate tab in SolidWorks, you'll see a Mass Properties option. And when you click that, it's going to pull up this window. And mass is really easy. Just say mass, 4.21 grams.
What's the material now?
The material is pine.
Okay.
And just note that that's based off of how you built your part. If you built your part in, you know, inch, pound, square, it's going to give you it in pounds. It's going to give you the weight in it. If you did it in, I'm in mmgs, so millimeters, grams, second, it's going to give me it in grams, basically. All your calculations are in metric, so you want it in grams or kilograms. If you don't want to do the calculations, you can go into options, and using custom setups, I can just say I want it in kilograms instead. And if you do that, you'll notice that
The density is
it gives you 0.
I was honestly a little upset.
Anyone have an idea why? If I'm at 4.21 grams and I change it to kilograms and only have 2 decimal places, I'm not going to see anything, right? So, going into these options again, you can say how many decimal places I want. And from there, you'll get your numbers. You'll be able to scale it and actually get it in kilograms. Now, the tricky part is always, you scroll down. You won't need to know this, but if you take with ACE&E, like the CSWA, the Certified SolidWorks Associate exams, sections of exams, this will give you your center of mass of the part. You might have to calculate that as well. That will tell you it. And then you'll get 3 chunks, and these are going to be your moments of inertia. And it's really important that you understand what each one's saying. So I'm going to pull this a little bit more into view.
So the center of mass and the mass moment of inertia, everything is going to be relative to what coordinate system?
That's the points I'm getting to.
Okay, go ahead.
So the center of mass is always going to be based off of where you made your model. So if I go in and if I just exit out of this and I show you where my origin is, I happen to have made my part with the origin right in the middle of it. I happen to have made it on a flat, on my top plane, right at the middle, and extruded it upwards. It's going to define your distance to the center of mass from that point. So that means you got to be careful about where you place your origin points if you want to make it easier on yourself. One thing that SolidWorks does have that might make it, say you do make this massive part and it's at the wrong spot, right? You're going to remake it. No, SolidWorks allows you to do something cool. If you go under reference geometry, you can create your own coordinate system, and I can define, say, somewhere like that. And what you can do is I can say, let's just do an example. So say I wanted my coordinate point right there. I can go in and I can make a new coordinate system at whatever point I choose on my model. And when I go in and do mass properties this time, what we can say is under options, if you look at here, it's going to say report coordinate values relative to default is going to be the part default. But if we scroll down, I can say there's my coordinate system that I just created. So if you notice, center of mass is now with reference to that point. So if you ever need to change it, you can just define a new coordinate system. Now, moment of inertia works the same way. If you look at this first one, it's going to say principal axis of inertia and principal moments taken at the center of mass. So basically, it's going to look for that point right there, as defined in the I, X, and Z is your center of mass. So X is going to be about your X, Y is going to be about your Y. The thing you got to be careful with is that coordinate system is different from the one down here. So if you're looking at here and saying, I want to know what it is about this Z, well, you're going to have to look at it at the Y with how it's reported, at least for those numbers. If you look down, you can say taken at center of mass and aligned with output coordinate system. So basically it's going to be at this coordinate system, this point, aligned with this. So those numbers are going to change a little bit. If you notice though, PY here, which is this way, is the same as Z down here, right? It's the same numbers because it's just how you label your axes is different. And then this last one, same type of deal, is just taken at the output coordinate system, which means it's my origin, which is where I started building the part from. So you have 3 sets of values of moment of inertia. You just got to be careful which one you're actually using. Don't worry about these numbers, only care about PX, PY, PZ, or Z, at least for this one. SolidWorks gives you a bunch of other very useful numbers, but for, say, this second one, it's going to say LXX. That's, you know, x-axis in the direction of x-axis, right? That's basically just saying around the x-axis, and that's the value you care about. So out of this big list, you're only going to care about LXX, LYY, and LZZ. Everything else, it's useful, but you won't have to use it. And that same thing goes for the other one. This is nice because it just gives you the values right away because it's at your 0, 0. But this is the mass properties tool. You're going to have to use it for everything you do because everything has mass, everything's going to spin, stuff like that. But the big takeaway is the evaluate tab, mass properties, and just be careful with what moment of inertia number you're going to be using in either your calculations, your codes, what you're reporting, what you're checking, stuff like that. But for the most part, it's very straightforward to use, and that's really all there is to it.
Okay, any questions?
Yeah, can you go back to defining that second coordinate system?
Yeah. So this is like more of an advanced feature. If you take to define a coordinate under reference geometries, you can define a coordinate system, and basically all it asks for is it asks for a point, and then you can define what direction the x-axis goes for. So if I define, say, this point this time, I want my x-axis to go this way. I can define a pointing, you can use the arrows to change its direction. Just harken back to the certifications test. There's a CSWA, which is the first one. CSWP is a professional certification. You'll have to do stuff like this in the problem. It just makes it a lot easier because you can just make your part and then define what you want to do with it.
Any other questions? Any question? How to find the mass, center of mass, and mass moment